For exercise 2, we're going to be creating a pre-flop score list. So just a list of all the scores from all the possible combinations of 2-card hands that exist. So there's 52 cards. We want to deal them out so that every single possible combination has a score attached to it. So if we get a list of all those scores, then we can compare how our score is to the others. So let's just say we have a score of 100. Let's go above here, right? Or 92, like, all right, what does this 92 mean in context? Well, we need to find the scores of all of the other combinations of 2-card hands so that we can place it somewhere. So is it in the bottom 10%? Is it around the 50th percentile? Is it in the 99th percentile? Where is this score located? So that's, so in order to do that, we need to find a list of all of the scores. And to help us out here, we're going to use this itertools. This combinations function over here from the itertools module. So itertools is part of the standard library. This function, what it does is you give it 2 arguments. The first is the iterable that you want to make combinations of. So in this case, it's just a range object. So this is just like the 52 cards. And this is just the number of cards it's going to choose. So here it's going to choose 2 of these 52 cards. It's going to do so without replacement, so it won't choose the same card twice, like it'll never be 10 and 10 or 20 and 20. The order also doesn't matter, so the combination 8-10 and 10-8 will not appear. That's the same, it's considered the same, and poker is also considered the same, so that is good. All right, so this function right now, all it does is iterate through all of these combinations. So you can see the for loop. So this creates that iterable of all the possible 2-card combinations. We unpack each number. So it's going to return a tuple of numbers, right? It'll be like 1, 8. So it'll unpack those numbers over here. And right now it's just going to print it out to the screen. This is just for demonstration purposes. You'll be deleting this, it says it right here, and then writing the actual code for the function. But I wanted to do this at first so you can see what's happening. You can see all the different combinations. And this function is very nice. It just does all of this magic for us right here. So I'm not going to scroll down to the end, but it does create all those combinations. Now it's up to you in order to, figure out what the pre-flop score is for this. So what we're going to do is we're going to create a list called scores, and then we're just going to use our function that we just did. And let me delete that. We're going to pass in a hand. So it needs a hand over here, right? So we're going to use this over here. So we're going to create a hand object. And we have to have a card object as well. So say num1 and card of num2. So we don't have card, no, we do have card imported, so that's good. So we're going to create the hand, pass it over here. We're going to get back the score. That's what this function returns, right? So it returns this score. And then what we're going to do is just append it to the scores list. And then the last thing we're going to do is we can return, I want it to be sorted, and this will make it easier to figure out how many are less than or greater than it, so we can figure out its place. Okay, so let's do this. And now I want to do pre-flop score list, and let me just print it out. It'll be a lot of numbers because there's about 1,300 combinations over here. So these are all the possible scores. So the highest score is 204. This is for ace. So there's 6 possible combinations of aces, like ace of spades, ace of hearts, ace of spades, ace of diamonds, and so forth. And then the lowest combination of the lowest score is 17. I believe that is with 2 and a 3 that are not of the same suit. And these are all the scores in between. Now, it's not necessary to know which ones they are attached to, like, all right, which cards make a 64. What we're going to do in the next exercise is just figure out how many of these are less than our current hand, and that will indicate how good, how strong of a hand we have. So if we have 200, or just say a score of 180, we know it's better than all of these over here. So it's a very good hand, right? Like it's just a much better hand than the vast majority of them. Anyways, so that's how you create this one. That's how you finish this problem. It's just iterating through all the combinations, creating the hand out of those combinations, calculating the score, appending the score, and then returning those sorted. And one last thing that I forgot is to do the assert statement over here. So it's just checking whether the last 20 are correct. And these are the last 20 scores. So nothing happened. So it looks like we got everything right.